Autonomous equipment maintenance by operators is an essential part of TPM in any company. Each member of the workforce must understand and adhere to the philosophy of operator maintenance before real progress in TPM can be made. Above all, this means keeping equipment clean. It also means learning the skills needed to maintain it. An autonomous maintenance program is implemented in 7 steps or stages. Operators implement what they have learned at each level of the training before moving on to the next level. The 7 steps of autonomous maintenance include initial cleaning, improvement activity to address the causes and effects of dust and dirt, development of cleaning and lubrication standards, instruction in general inspection techniques, followed by autonomous inspection conducted by operators, development of standards for workplace organization and housekeeping, and finally, full and independent performance by operators of all autonomous maintenance activities. During the first step, operators remove dirt, grime, and contaminants that have accumulated in and around the equipment. This allows its condition to be determined by sight and touch. During this period, operators discover and treat problems revealed through cleaning. They become curious about the equipment and ask questions. As their knowledge increases, operators develop a sense of ownership and pride in their equipment. In the second step, operators learn to control the sources of dirt and other contaminants. They develop techniques to prevent dirt from scattering and sticking to surfaces, and adjust the layout to help clean and lubricate hard-to-reach areas. During this step, operators also learn how to implement equipment improvements and develop ideas for their own small group activities. During the third step, operators establish new standards for daily cleaning, lubricating, and bolt tightening, based on techniques they have developed and tested. The principle behind this step is that operators are more likely to adhere to standards they develop themselves. During the fourth step, general inspection, operators are taught equipment fundamentals, such as bolting techniques and the basics of hydraulics, pneumatics, and drive systems. Then they apply this training to identify abnormal conditions in their own equipment. This training helps operators develop basic inspection skills by broadening their knowledge of equipment design, function, and proper operating conditions. At this stage, they can actively correct deterioration and make simple repairs. During the fifth step, autonomous inspection, operators create checklists to follow for daily and periodic inspection. This encourages operators to manage their own equipment effectively using their own tools. Over time, operators become increasingly sensitive to abnormalities in operation and gain expertise in correcting them. During the sixth step, supervisors identify aspects of the workplace that should be controlled to make operations more efficient and to ensure quality and safety. They set standards for control and storage of tools and jigs, for example, for work in process, products, parts, rejects, and other inspection and control activities. Then, operators working in their groups develop ways to promote adherence to these standards, for example, by using visual controls. This important step increases the scope of operators' autonomous maintenance activities. It involves them in daily workplace management by requiring them to creatively control their own adherence to standards. In the seventh step, autonomous maintenance is fully implemented. Operators help achieve company goals through independent small group activities and contribute to equipment improvement by keeping and analyzing mean time between failures records. Group activities during this final period heighten operators' awareness of the company's goals and give them a thorough understanding of costs, including maintenance costs. Here is the 3-year master plan for implementing autonomous maintenance drawn up by project teams at steel products manufacturer TPM Industries. During the initial cleaning period, the entire workforce worked to remove grime that had built up on the equipment over years. In the beginning, operators cooperated in the campaign, but didn't see much value in it. As cleaning exposed more and more examples of deterioration, however, they began to see its importance to their own equipment. Equipment as dirty as this became clean and easy to inspect. Once equipment was thoroughly clean, no one wanted to see it get dirty again. Keeping it clean became natural. At Topi's Toyokawa plant, many improvements were implemented to address problem areas exposed in cleaning. For example, a group in a welding process addressed the problem of excessive friction and buildup of contaminants. Here, the welding flash powder exhaust port was improved to increase exhaust effectiveness. This eliminated cylinder problems and excessive friction and made cleaning easier. One by one, many similar improvements were made. For example, here on the press line, bits of scrap from the punching process fell onto the conveyor, causing it to jam and shut down. Consequently, the press had to be stopped frequently to remove scrap. This improved skirt was added to the conveyor belt. This simple improvement quickly eliminated conveyor failures due to flying scrap. General inspection training at Topi Industries was conducted in 2 stages. Group leaders were taught bolt tightening techniques and the basics of electrical, hydraulic, pneumatic, and drive systems. The leaders then passed on this training to the members of their groups. Once the 2-stage training process was complete, operators prepared checklists and began to conduct general inspections. Equipment diagnoses are made at every step of the general inspection. If a machine passes, the inspection continues to the next step. After a general inspection, group leaders and supervisors meet with operations and maintenance managers to discuss equipment diagnoses and review the progress of small group improvement activities. Group members then discuss what actions to take to address needs revealed by the inspection. They also add items to the general inspection checklist that anticipate or prevent the problems exposed by the diagnoses. Each small group at the Toyokawa plant maintains a bulletin board to promote their autonomous maintenance activities. The group's current improvement focus is prominently displayed, and its progress can be monitored at a glance. The group bulletin boards foster a competitive spirit among the various groups that has resulted in a strong operator training program. Successful autonomous maintenance requires operators who actively contribute to the achievement of 0 breakdowns and 0 defects. Operators who know their equipment well, who can detect abnormalities early in the causal chain and correct them quickly. Operators are not expected to know how to repair their equipment, however. Their contribution to the maintenance effort is the well-developed ability to detect abnormalities in machine functions. An abnormality is a defective or deteriorating condition. We may not be aware of its existence until it causes a failure or produces defective parts. This abnormal cause must be identified and treated to prevent the failure or defect from recurring. That's why skilled operator diagnosticians are an essential part of TPM. A PM and replacement program that is not based on actual plant and equipment conditions will generate unnecessary expense over time. Standards for inspection, adjustment, and replacement should be studied and upgraded before being incorporated in a planned maintenance program. The maintenance department's first responsibility in TPM is to guide and support operators' autonomous maintenance activities. Therefore, planned maintenance work should be scheduled so that work performed for the operators is done quickly and correctly, and equipment deterioration is checked. As operators assume responsibility for daily inspection and maintenance personnel will have more time to analyze failures and identify weak points in facilities and equipment, to extend the life of equipment through maintainability improvements, and to develop procedures that reduce maintenance costs. Over time, these activities promote reconsideration and revision of equipment standards, which also reduces waste. A planned maintenance program is even more effective in reducing maintenance costs when condition-based maintenance techniques and predictive maintenance are adopted. To get the best results from maintenance on a limited budget, it is important to be selective. Data from past years should be collected, future production and equipment plans estimated, and maintenance plans drawn up, starting with equipment items that will yield the best results. This table shows a ranking system developed at one company to help prioritize equipment improvements. Equipment is ranked numerically, based on the answers to questions such as the effect of failure on other processes, the value of scrap losses, the mean time to repair, or the monthly cost of repairs, for example. Priorities are always changing based on production plans, new equipment, maintenance improvements, and so on. They should probably be reviewed annually or biannually. The maintenance department is responsible for preparing annual maintenance plans, which help guarantee the reliability of equipment over its predicted lifetime, from installation to retirement. It must also prepare a wide variety of maintenance and equipment standards so that maintenance activities can be carried out efficiently. Technical training is essential for effective autonomous maintenance in operations and for preventive and corrective maintenance in the maintenance department. Technical training for operators rarely pays off unless operators are already interested in their equipment. The best time for operator training is during preparation for the general inspection, when operators actually need the instruction to develop and conduct equipment inspections. Solid technical training for maintenance personnel is also an essential part of TPM development. The scope of equipment maintenance includes many types of equipment used in many fields. Even at different companies in the same industry, the same types of equipment may be more or less important or used differently. The same parts and systems are common to most equipment, however. Thus, the curriculum of a fundamental equipment maintenance course covers parts common to all types of equipment. Take a moment to look over this example of a basic equipment maintenance course. It is made up of 5 3-day units covering a variety of topics. For example, Unit 3 covers handling and maintenance of shafts, mounting, shrink fitting and extraction techniques, and fitting sleeve bearings on the first day, followed by testing, measurement, and recording techniques, interpreting temperature records, lubrication experiments, and bearing lubrication on the second day, ending up with repair of axles and bosses and bearing assembly basics on the third day. Companies should develop a program that integrates basic topics such as these with others that are tailored to actual company requirements. Maintenance personnel are trained in electrical work, mechanical work, or machine maintenance. They can make mistakes when they work on a problem involving more than one of these fields. Therefore, maintenance personnel trained in electrical work should receive a basic course in mechanical maintenance and vice versa. TPM helps companies work toward the ideal of maintenance-free design. In this system model for developing maintenance-free equipment, the design and assembly stages are shown on the left. The operation and maintenance stages are shown on the right. Let's take a closer look at both these stages. The life cycle of a piece of equipment begins with a design aimed at eliminating maintenance as much as possible. On this diagram, the cycle begins at the lower left of the circle with maintenance-free design. Following the arrows up and around, the equipment is manufactured, installed, and tested before beginning normal operation. Once the early failure period of the equipment is over, operating data is fed back to the maintenance-free design stage through commissioning control. This cycle at the design and installation stages is known as maintenance prevention, or MP. It is also called early equipment management. Now, let's look at the operation and maintenance side of the model. Starting at the top of the diagram, in response to inspections, parts are replaced, equipment improvements are proposed and planned, and then the improvements are monitored before putting the equipment back into operation. Notice that this data is also fed back to the maintenance-free design stage. In this cycle, there are 3 maintenance data feedback routes for improvement. 1. To improve the maintainability of equipment currently installed, or maintainability improvement. 2. To improve maintenance work or the maintenance system, or methods improvement. And 3. To promote maintenance-free designs for new equipment, or maintenance prevention. A system for managing equipment in the earliest period of its operation is essential if feedback of these 3 types of information is to bring equipment closer to the ideal of maintenance-free design. Let's review the main principles of TPM in terms of implementation. As this figure suggests in the first column, TPM is intended to increase overall equipment effectiveness. to establish and maintain the ideal relationship between equipment and manufacturing personnel. To achieve this, TPM sets two goals: to eliminate the 6 big losses and to maintain equipment at its full potential through the 5 developmental activities already outlined. Every company is at a different stage of development. While each company must tailor its implementation plan to specific needs and plant conditions, a general approach that staggers the introduction of the 5 TPM activities, as outlined in this chart, has proven successful at many companies. To fully realize the potential of TPM, everyone in the workforce must change the way they think about equipment. This change in consciousness takes place more easily when we begin by improving individual pieces of equipment and involving operators in autonomous maintenance development activities. Changing the way operators view their own equipment is the first objective in implementing autonomous maintenance, so start cleaning right away. Equipment improvement projects can be initiated by setting up teams and asking the engineering and maintenance staff to identify equipment problems. Be sure to allow sufficient time to involve everyone in equipment improvement activities and to prepare operators thoroughly for autonomous maintenance. Unless all members of the workforce understand that they alone have the power to eliminate losses, the TPM program will not succeed. Once attitudes change in the workplace, the next step is to conduct skills training and begin developing a planned maintenance system. Planned maintenance is most effective when the division of work between operators and maintenance personnel is clearly defined and adhered to. Operators' independent efforts help maintenance achieve higher levels of equipment effectiveness. At the same time, maintenance personnel support operations directly with prompt servicing and repairs. Facilitating this cooperative effort is an important goal of maintenance planning. Technical training to increase maintenance and operations skills should not be introduced until operators develop an interest in their equipment. Ideally, such training should begin when operators are already involved in daily inspection and cleaning and in group equipment improvement activities. Similarly, a system for early equipment management should be built on a firm foundation of ongoing equipment improvement activity and planned maintenance. At this point, the skills and awareness necessary for effective data gathering and analysis will already be developed. Once this equipment management system begins to function, however, extraordinary results can be achieved through TPM. In conclusion, we offer the following advice from TPM's developer and top consultant in Japan, Seiichi Nakajima of the Japan Institute of Plant Maintenance. Top management must establish clear TPM policies and objectives if real change in equipment and attitudes are to occur. Genuine support at the top encourages everyone to develop the skills needed for success. Better leadership and management pave the way for improvement in plant facilities and personnel. Unless company policies and goals demonstrate and demand the very best performance from everyone, fundamental transformation in equipment and personnel is impossible. As this figure illustrates, TPM is promoted through clear, top-down policy and goal setting, combined with bottom-up autonomous small group activity. When company policies are unequivocal and goals are set high, employees become highly motivated, and the objectives they select for small group activity are more likely to be consistent with company goals. This integration of top-down and bottom-up management is an important strategy in TPM. In Japan, companies implementing TPM compete annually for the prestigious PM Prize, continually boosting the overall efficiency of plant and equipment beyond current goals. Adopt this habit of continuous improvement in your own plant, and you will undoubtedly succeed in your TPM activities.